Welcome back to the Algebra 2 series. Today we're talking about the average rate of change, and in this case we're trying to simplify the difference quotient that represents the average rate of change from an untethered point to a tethered point. And in this case the tethered point is the point 2 comma f of 2, as we see here, and the untethered point a comma f of a, average rate of change being the slope. So we'll write that difference quotient out in a minute. But notice that for this example we have x cubed, so we have a cubic function that we're working through. And if we just write this out as the difference quotient f of a minus f of 2 over a minus 2, then what we're really representing here is the slope, which is the y2 minus y1 over the x2 minus x1. And we've learned as we've practiced these that the nice part about the computation is that the a minus 2 that's in this denominator will factor out, and we'll see that happen in this example. So starting with the problem f of x equaling 3x cubed minus 2x plus 5, we'll write our difference quotient here, f of a being 3a cubed minus 2a plus 5. And I'm going to put this in a parentheses, even though it's not necessary here, minus f of 2, which would be 3 times 2 cubed minus 2 times 2, and then plus 5. That's all over a minus 2. So as we start our problem, this is just a matter of computing this. In the end, we end up with 3a cubed minus 2a plus 5. And here we see an 8 times 3, or 24, minus 4, or 20, plus 5, or 25. And I'm subtracting that 25 because of that minus. This is all over a minus 2. To simplify one more step here then, gives us the following cubic in the numerator, 3a cubed minus 2a minus 20, and that's all over a minus 2. We talked a bit in class about how since this denominator is going to cancel out, then a minus 2 should be a factor of that cubic. And what it does then is it gives us a chain reaction. The chain reaction being, I know a minus 2 is a factor, and therefore we should be able to rewrite this cubic in such a way that we can group it. So we start with the 3a cubed here and ask ourselves, if I were to factor an a minus 2 out of here, what term would we want as our second term? And in that case, then it would be a minus, a 6, and an a squared. So if I were to factor the 3a squared out, I'd get an a minus 2 as the other factor. Well, if you notice, there is no 6a squared up in that numerator, and so we'll have to add that back in, 6a squared added back in. Now, if the 6a squared is part of a term that has a minus 2 as a factor, then the next term must be minus 12a. That would give us an a minus 2 as the ratio. But we don't have a minus 12a, we have a minus 2a. So I better add 10a back in to make that negative 2a. And then finally the minus 20. And lo and behold, you'll notice here that a minus 2 is also a factor of the last two. I know there are many other ways to tackle that cubic. You could use synthetic division or long division, but in this case, kind of a unique little solution here. 3a squared times a minus 2 plus 6a times a minus 2, and then the last term plus 10 times a minus 2. As you see, a minus 2 is a factor of all three of those, leaving, oh, excuse me, let me rewrite that there. A minus 2 is factored out, and what's left over in the numerator, 3a squared plus 6a plus 10, and that all over a minus 2. Lo and behold, it cancels out, and our final expression, 3a squared plus 6a plus 10, is representing the slope from the fixed point to the non-fixed or untethered point in this example. Isn't math fun?